Well, hello everybody. Thank you very much for joining our webinar today. My name is Tom Reu. I'm a consulting application engineer with Chelsio Communications. And we have some really interesting and exciting information to talk about regarding Chelsio's products, iWARP RDMA, and Storage Spaces Direct from Microsoft, which is part of Windows Server 2016. Helping me out today will be Paul Schnackenburg from Export IT Solutions, which is based down under in Australia. So thank you very much, Paul, for getting up so early to join us, as well as Dan Lovinger, who is a principal software engineer from Microsoft Windows Development Group. And once again, gentlemen, thank you very much, and thanks for taking the time to participate in this webinar. So for the agenda for today, first I'll have a few minutes to share an introduction to Chelsio and its products. Part of that will be an introduction to RDMA and iWARP in case you are not that familiar with those technologies. Then we'll have Paul come up and come talk about S2D, Storage Spaces Direct, and share some of his experience deploying it on Chelsio hardware. And then last, Dan will share some information from his perspective, including some benchmark results that Microsoft has collected in their labs, and I'm sure everybody will be really excited to hear some of that. We should have some time for Q&A at the end of the presentation. If you think of a question during the presentation, please click the question mark and enter your question so that we can address it during the Q&A session. This webinar is being recorded and will be available on the Chelsio website and perhaps others in the near future. So before we get going, I just wanted to ask something, and I'm going to launch a little poll here, and just to see how much you guys know about what we're talking about here. So, how many of you guys know anything about RDMA, iWARP, and Windows 2016 with Storage Spaces Direct? And we'll give everybody a couple minutes to answer. Okay, it looks like most everybody has responded. So the results are some know a lot, some know a little, and some people have no idea, which is kind of what I expected to see. So excellent. Now let me hide these results and let's go on to the next. So for those of you who don't know much about Chelsio, Chelsio's been around since about 2000. Our products are Ethernet adapters based on our custom design ASIC. Currently shipping products are centered on two particular ASICs. One is called T5, and it should be of no surprise that the second one is T6. Chelsio has shipped about 1.2 million ports since our inception. The adapters are for very high performance with high bandwidth and low latency. Chelsio's forte is offloading, which means that the Chelsio ASIC performs many of the functions involved in the network processing on the ASIC instead of on the CPU. We call our product, or we center our product around what we call a unified wire architecture. This is because with the same software, hardware, and firmware, we can support all these features and protocols on our card simultaneously. Our adapters are used in many places where high-performance networking is required, such as storage, high-frequency trading, high-performance computing, and others. One new feature that was added on T6 is the onboard encryption engine. This engine allows the user to offload IPsec, TLS, and SSL processing onto the chip. It works in two basic configurations, first being coprocessor, where the CPU accesses the crypto engine and does the encryption locally, and second is inline, where the data going out or coming in over the wire is encrypted or decrypted as it's transferred. This is a block diagram of the T6 ASIC. Its design is very much like the T5, with the exception of the crypto engine that you will see right here over by the PCI interface. Now, I'm sorry, I lost my track here. On the T5 as well as the T6, we have this thing called the embedded layer 2 Ethernet switch, which is very useful. It can be used for virtualization as well as filtering. With this switch, we will soon be rolling out support for clusters in both Linux and Windows that do not need a switch. So look for information on this on the Chelsio website in the next couple of weeks. Kind of exciting that you can be able to put together a cluster without the need for a top-of-rack switch. I'm sure everybody will agree with that. Oops, I have to turn something off here. There we go. All right, so let's get on to the task at hand. One of the most beneficial features that Storage Spaces Direct uses on the Chelsio card is the iWARP, or RDMA over TCP. We will talk a bit about the advantages of iWARP shortly, but first some background. RDMA stands for Remote Data Memory Access. It is essentially a way to move data from machine to machine using the hardware of the RNIC, and we use the RNIC term for Remote Data Memory Access NIC, or Network Interface Controller, so to indicate that it's not just the NIC. And by using the RNIC, and it barely uses any of the CPU to move all this data. In addition to handling the data transfer, the RNIC also handles protection of memory spaces. So in other words, you can't go scribbling on other people's memory areas that that they don't want to have written to. So what we end up with is a high bandwidth, low latency data transfer pipe that doesn't need a lot of CPU to make it work. So what is this iWARP thing I keep talking about? iWARP is technology that implements RDMA over a TCP IP network. In comparison to some of the other RDMA techniques available, we feel, and hopefully Paul and Dan will back me up, that iWARP is the best implementation. It has been around for a few years and is inbox, meaning provided in this standard distribution, in the Open Fabrics Enterprise distribution, or if you've heard of the term OFED. It uses IB verbs, and as a result, many, if not all applications that are written to use InfiniBand will work with iWARP with no changes at all to the application. But anyway, back to TCP. Because of the Chelsio ASIC design, the ASIC implements iWARP and TCP IP in silicon. This allows processing of packets that would normally need to traverse back to the CPU to be processed right on the chip. iWARP is engineered to use what you would call typical or traditional Ethernet. As a result, all the congestion and retry mechanisms that may be needed are implemented, tested, and proven in the TCP IP infrastructure. There's no need to go out and buy all new switches that implement features like DCB, or data center bridging, or QCN, quantized congestion notification. Let's face it, basically the internet runs on TCP IP. Without it, there would be no internet. The technology works. And this is a side note for me, the other Ethernet RDMA technology keeps trying to reinvent itself so that it can have all the features of TCP and IP and iWARP that they already have. iWARP is a standard that is maintained by the IETF. That is, in this lists the number of RFCs that define iWARP. In addition, several vendors provide iWARP products. Us, of course, Intel, and most recently introduced into the mix is Cavium with their QLogic stuff. In Windows 2012, when Microsoft made what I consider to be a wise decision to add iWARP as one of the transport mechanisms for S2D Direct. This has been able to roll forward, and now iWARP is one of the transport mechanisms for Storage Spaces Direct. To talk about Storage Spaces Direct and some of the experiences with it and Chelsio iWARP, I'd like to turn the presentation over to Paul. So Paul, you're up, and I'm going to give you the screen.
Thanks, Tom. Hi, everyone. Thanks for taking the time to attend the webinar today. So I'm going to give you a quick introduction to Storage Spaces Direct, how it works, and then talk a little bit about what I've done with it and my implementations. So in Windows Server 2012, we had storage spaces. So this was Microsoft's first entrance into software-defined storage. And you had separate file servers and separate disk trays, which worked well for larger environments, but weren't particularly applicable to smaller environments. So in Windows Server 2016, we now get Storage Spaces Direct, which can be deployed in two flavors. As you can see here, we have disaggregated. So again, the servers are separate, but instead of the disks, the hard drives and the SSDs being in separate disk trays, they live inside of the servers themselves. And that also opens up the option for the hyper-converged deployment flavor, where the Hyper-V servers themselves running the virtual machines are also storage servers, and then you have the hard drives and the SSDs internally inside of those servers. And because the drives are also internal to the servers now, we have more flexibility in what type of drives we can have. So in Storage Spaces, the old one from Windows Server 2012, you could only have SAS drives. And they had to be specific SAS drives as well. Whereas with Storage Spaces Direct, we can now have SATA drives as well, and we can have NVMe, and I'll talk a little bit more about those on a separate slide here coming up right now. So we all know SSDs are fast, but they're still attached to the SATA or SAS bus. So here's some sample pricing, and you can see, well, from a pure price per gigabyte point of view, you would definitely want to go with the SSD. However, if you look at the performance of these types of drives, because an NVMe drive is essentially an SSD, it's still using solid-state storage, but it's connected directly to a PCI Express card. So the overall performance is much better. So you get almost over 3 times the performance there on these sample ones, and your CPU overhead is a lot lower. So NVMe certainly is an interesting storage technology if you're considering Storage Spaces Direct. And of course, that's the point, right? Like in earlier versions or in earlier times before Storage Spaces Direct, we couldn't actually share NVMe storage. You could put it into one server, and it could have some fast drives, but there was no way of sharing it. So caching, if anyone has used Storage Spaces in 2012, and then in 2012 R2, we got tiering, right? So we have an SSD tier and a hard drive tier, and the hot blocks are moved from the hard drive tiers to the SSD tiers. But that was a scheduled job that happened once per night by default, right? And if you had high churn workloads, maybe that wasn't super efficient. So Storage Spaces Direct takes a different approach. So we have, if you're combining SSDs and NVMe, your reads are not cached, but your writes are cached. Whereas if you have hard drives together with SSDs, both reads and writes are cached on the SSD. So this essentially gives you real-time tiering. So instead of the blocks being moved at night, once per day, you get a real-time advantage of using the SSD storage. Excuse me. And it's automatically created for you and managed by Storage Spaces Direct. So you don't need to go in and set it up like you had to in Storage Spaces. And then the writes are moved from the SSD tier once they've been or from the NVMe, whichever, when the drives have the time, and they are very efficient because they lay them out in nice sequential writes for the hard drives, really taking advantage of the speed there. And you want to set aside 5 GB of memory on your hosts to manage this. And the drives are also dynamically bound to the hard drives. So as you change the number of hard drives in your system, you automatically get binding for the cache drives to manage that. So again, it's another way that storage spaces is more hands-off, more automatic, smarter, perhaps you could say, than storage spaces, and it gives you an easier management of the system. It's much easier to expand the storage spaces direct setup than it is with the storage spaces, the old storage spaces. So when you have 2 nodes in storage spaces direct, you get 2-way mirroring. When you have 3 nodes, you get 3-way mirroring. 3-way mirroring is the best, gives you the best performance, but it's not very disk efficient. If you want, 20 terabytes of storage, you've got to buy 60 terabytes of hard drives and SSDs because you can only use 1/3 of it. When you get to 4 nodes in a storage spaces direct cluster, you can do something called mirror accelerated parity. And if you're thinking of this in terms of RAID, this is essentially combining RAID 1 and RAID 5 on the same volume. So you have a smaller portion set aside for mirroring, and that's where writes are cached and then written into the parity tier of the volume. And this gives you between 60 and 80% disk efficiency. So if your budget can't stretch the 3-way mirroring all the way, you could consider mirror accelerated parity, as long as you got 4 or more nodes in your cluster. And you can combine drives in storage spaces direct, especially if you're building this yourself. So you can do all flash, you can do just all NVMe or all SSD, or you can combine them. If capacity is your aim, you would put SSDs together with hard drives, or if you want to balance, you can do NVMe's and hard drives, or even all 3. You can have all 3 tiers if you want to. And your resiliency type sensor, this is equivalent to what you would use as RAID in a traditional setup, right? So you have your mirror, either 2-way or 3-way mirroring. And as noted here, Hyper-V really appreciates the mirroring setup. Parity is for your sort of cold storage or stuff that you do not need to access, at least not at the very high performance. And then the mirror accelerated parity can be used for certain workloads. And we just skipped over a slide. Sorry, I clicked twice on REFS. All I was going to say on that slide was essentially that you want to make sure that you use the REFS file system. There you go. Thanks, Tom. You want to use the REFS file system for storage spaces direct. It's got all of these benefits that are on the slide here. The only thing missing compared to NTFS is the duplication that is coming, but there's so many other benefits, especially for your Hyper-V workloads, that you definitely want to go with REFS on your storage spaces direct volumes. And your networking, as we said, you can use standard 10 gigabit or Ethernet or faster Ethernet networking, but of course using RDMA is going to give you the best performance. And it's not that hard to set up. Now you want to set aside 10 to 15% of your overall volume for caching, and that's space that you won't be able to use for actual storage. You want to also reserve some space in your pool so that storage spaces can do its automatic rebuild. So another improvement over storage spaces is that if you have a failed drive, replacing a drive, setting one up, and adding it in is really easy, especially if you have a bit of extra space reserve. And the default domain is a node, so a single server fails while all the drives in that node, of course, aren't available to the storage spaces direct overall. You can also tag racks. So if you have, spread 4 nodes in one rack and 4 nodes in another rack, you can tag that so that storage spaces direct can be rack aware or take that into account when it spreads its data out. The maximum limit today is 1 petabyte for a single cluster, and you can have up to 16 nodes and 416 disks. Okay, so in my experience, I've set up 2 clusters now using Chelsio's networking gear. iWARP is a lot easier to set up, right? So if you're building a really big data center and you have networking engineers and stuff, well, maybe the other technologies could be a consideration. But for a smaller deployment or an easier and quicker deployment, not having to fiddle around with DCB is definitely preferred. It's just plain old TCP/IP, and it just works. Configuring your network traffic classes then is just used, you just use the built-in SMB3 NetQoS policy and traffic classes. So it's quite easy, and the documentation is good, so it's quite easy to set up. You can use any switch. I'm using a Dell 10 gigabit switch and didn't need to do any configuration on it at all. And that also means that you can swap them out, right? So there is no tie between the NICs and the switches in configuration. So switch dies, you can just buy another one and plug it in, and it just works. You want to use the new switch embedded teaming, which is also part of Windows Server 2016 for NIC teaming when you're using Storage Spaces Direct. Actually, enabling Storage Spaces Direct once you've set it all up is really simple. So in the technical previews for Server 16, that was quite complicated with lots of PowerShell to run, but now you just simply do enable cluster Storage Spaces Direct, and it figures out the optimal layout for your environment. Definitely want to look at enterprise class SSDs. Don't use the cheap SSDs from your local computer store, because they won't be able to handle the load and they won't give you good performance. Nor will they last, because they've only got a certain number of writes on them. And use REFS, I've already mentioned that. And I'm going to hand over to Dan.
Thank you, Paul. Dan, I've given you control if you would like to do your thing.
Okay, thanks, Tom. Paul. I see that we had a few questions pop up during the last segment. I can take a minute to answer those right now if folks would like.
However you would like to do it.
Fresh. So the first question is, can you use NTFS and data deduplication with Storage Spaces Direct? Yes, and that's actually the way we support right now. It's a fully supported option with Windows Server 2016. The support for REFS and data deduplication is coming, but that's the way you can consume it right now. There was a second question about whether there is a performance advantage to having VMs hosted on a server that owns a copy of the data for the VM, assuming that reads would be local. Basic answer is yes, again, although with Storage Spaces Direct, the way the layout works is a little bit different than the question is pointing toward. With Windows failover clustering, we have the notion of a cluster shared volume, which basically locates where in the cluster the instance of REFS is running that owns the volume. And having the VM that is running on the storage owned by that volume co-located with that instance, that's where the modest performance benefit comes from. And then if there is a local copy of the extent of data that the VM is reading, yes, it will come local, and that's a second performance benefit. So that's the alignment to think about. In general, for storage spaces direct, there is no one single copy, unlike other software-defined storage solutions, which might have, if I have a three-way copy of, say, a VM's content, one copy is on node 1, one copy is on node 2, one copy is on node 3. Storage spaces direct distributed around the entire cluster, which gives us some benefits in terms of how fast we can recover from failures, because all nodes can contribute content in parallel for that rebuild and regeneration process. That's getting a little bit in the technical weeds, but bottom line, yes, there is a benefit to aligning things. But I would strongly suggest that in general, let's focus on the actual workload you're bringing in. You should find that strict alignment is not always required to get your loads running effectively. So on that note, let's go ahead and let's look at a couple of the performance results that we shared using Chelsio. This is one of the more recent ones. At the very top, you can see a red link out into our file cabinet blog where we shared all of this. And we'll look at that blog post directly and actually find other results that discuss Chelsio as well. But this is one we're particularly happy about. This is a 4-node cluster using Dell R730XDs. And what we've done here is we paired up Chelsio's T6 100 gigabit NICs, 2 per node, so 16 lanes of PCIe 3.0 each NIC, with 4 of Samsung's PM1725 NVMe devices, which are by 8 devices. So 32 lanes of NICs, 100 gigabits, and 32 lanes of NVMe storage. Which then, when we lash it all together with storage spaces direct and then run virtualized load, this is 80 VMs doing sequential scanning across content they have inside their VM storage. We're able to punch it all the way up past 80 gigabytes per second with less than 1.5 millisecond latencies at the cluster shared file system layer, which we think is an absolutely awesome demonstration of, sort of the hero side of, any extremely read-intensive workload. So this is fully resilient. I can lose storage, I can lose nodes, I can bring VMs back and forth, I can do servicing, and get back to performance levels like this. Particularly happy about this. The second result that I want to share is very high scale one. So this is now 16 nodes of Intel's S2600 WT chassis. These are their OEM white box systems. These are a standard 24 drive front face, which we populated with 4 of their P3700 NVMe devices and 20 of their S3610 SATA SSDs. These are their the high spec E5 2699 V4s in this instance. The previous example actually had a relatively mid spec V3 Haswell generation processor. And then we stand it up with the same type of virtualized load. In this instance, we're going all the way up to 704 virtual machines in the cluster. This is running with 1 VM per physical core in each system, doing a random read workload and achieving just about 5 million IOPS, which again we think is a best-in-class result. Shows iWARP running extremely effectively. just parenthetically, if we'd step this back to a read-write workload, we'd probably be expecting in the range of about 2.5 million, 2.7 million IOPS, and we do have results showing that elsewhere, but we didn't want to just do a big long layout. These are intended to show you where iWARP stands up, and it stands up very effectively, we think. So with that, I think I see one more question may have come through.
There's one. Is there a calculator for calculation expected 4K I/O with different disk mixes?
The strictest calculation to make is probably to be looking at the IOPS per node here. Per node, in the range of about 300 to 350, 400,000 IOPS is about where the software-defined storage stack limits itself. More practically, what I would tend to focus on, we like micro-benchmarks like this to show the absolute, limits of a system, but we generally find that not all workloads are pure storage IOPS bound. You want to be looking at latency. We also think the latency of our stack is quite excellent. You can imagine what it starts to look like. Say instead of doing 300,000 per node, that's 44 VMs per, so they're doing substantial IOPS per. You think about low queue depth, that generally is where we think the bulk of the market tends to sit. The absolute results let us rank relative systems, but then the latency is where we also think we shine. We're not showing that here. I believe we do have some results where we discuss that publicly if you go up there and look on the file tab. But in general, if you really have a specific question about specific hardware, that's where proof of concepts come up. Contact your favorite OEM of choice and see about assembling a system that you can directly sample into your workload of choice. That's, I think, the best answer I can give to that.
Thanks, Dan. I think we were going to go to the next slide, and you were going to talk a little bit about some of the resources, and then Paul was going to share some of his.
Yep. So resources for Storage Spaces Direct. The very first one will take you to our landing page for Storage Spaces Direct inside our documentation corpus. That will take you a long way toward increasing your understanding of Storage Spaces Direct in Windows Server 2016. Deep link about hyperconverged solutions. We are in those previous two results showing what we refer to as hyperconverged. If you're not familiar with hyperconverged, we're basically virtualized workloads on the same systems that are providing the storage. So it's a single compute and storage system that expands and contracts your requirements. And then some other documentation that I believe Paul contributed. If you're curious about the specific measurement frameworks we were using in the previous slides, we're using our disk speed tool and what we call VM Fleet. That's what lets us stand up all the VMs and run load through them into the storage. And you can see that on GitHub along with precompiled disk speed if you'd like to acquire that. And with that, I think one more question coming up about the throughput and performance difference of iWARP RDMA versus regular NICs. Well, I think Paul had one comment on that a few slides back, and generally it's significant. I think the specific numbers you may get different depending on the specific storage you have underneath you. Relatively slower storage, you may become storage limited, but numbers in the ranges of 30% plus are common in our experience.
Plus, on top of that, all the CPU you save by not having the CPU have to be involved.
Yeah, and that's generally what we're talking about when we say it got some percent faster. Is that if we're running CPU limited, and we give back a lot of CPU because we're using RDMA, we get to go that much faster in terms of IOPS or bandwidth, if that's also CPU limited.
Mm-hmm.
So that's how that trade-off works.
Well, also, if you're in a hyperconverged scenario, you really want your CPU resources for your VMs, not for your infrastructure. I'm seeing a question here, and I'll ask Dan to expand on this as well. The PowerShell QoS commands. Well, when I say you don't need DCB, you don't need to configure DCB on the nodes nor on the switch, right? Because iWARP doesn't require it. I don't think that commandlet requires DCB, does it, Dan?
No, we do not require DCB for iWARP. I'm not sure exactly which slide we're looking at for QoS. It might have been that.
I believe it's this one that's up there right now.
Okay.
Yeah, the new NetQoS policy and new NetQoS traffic class.
Okay. Well, I might let you talk about that.
Because I haven't done this for about 3 months, so I can't remember. But I don't actually think that they require DCB. I would have to look that up.
Yeah, I mean, the general notion of reserving some portion of your switch bandwidth for SMB traffic, well, that just generally, if that makes sense, that makes sense. Don't require that. Now there is a form of QoS that maybe is worth just mentioning briefly. In Windows Server, we do have the notion of storage QoS, so you can assign quality of service limits to each VM's storage performance. That's completely independent of DCB, anything in the network fabric. It's a general feature of the platform. So if you do want to assign, QoS and storage terminology to one set of VMs versus another set of VMs, that is supported in the operating system. And you can learn more about that by going through our S2D links and searching for storage QoS.
Thank you. Paul, is there anything you wanted to share on this resources for S2D, or you good?
No, I'm good, thanks. Well, there's a couple of articles in there that I've written for sites that I work for, and the last link there, just above Disk STD, is a recording from an Ignite session on the Storage Spaces Direct, a deep down level 400 session that was given by one of my Australian colleagues down here.
Excellent. Okay, so I'm going to take it to the summary, and then we'll go into any more Q&A that might come up. I think that this webinar is great. You could listen to me and take my word for it that iWARP is all good for S2D and everything, but I think it's absolutely fantastic that I have people of the caliber of Paul and Dan to help me out here and basically back me up. So what would be some of the advantages of iWARP over other transports? Well, it's Ethernet. Everybody knows Ethernet. Everybody knows it works. It's TCP, TCP/IP. It's mature. It's proven. It's been used for many years. It doesn't require, iWARP does not require a totally new infrastructure like Paul mentioned. He's got switches that he can swap out freely and not have to reconfigure with DCB or anything like that. And also we're mentioning that there are upcoming servers that are going to have integrated support for iWARP coming out sometime this year. So just backing up that iWARP is real. It's kind of taken some time to get into the mainstream, but I think we're going to start to see a lot more stuff. So there are there are handouts included in this webinar that you can pick up that talk about the configuration of a network for QoS with Storage Spaces Direct, and they don't speaking specifically to the fact that they do not require our DCB. Our cards, just so you know, we do support DCB, but we do not require it. It's not absolutely necessary. Lastly, just a highlight of Chelsio's Windows solutions. We have one of the most comprehensive ones out there, and we have a whole set of white papers on Chelsio.com for you to peruse and get more information and feeling for the Chelsio product, as well as Dan indicated on the Microsoft blogs. We have lots and lots of mentions on the blogs and in the file cab, and you know, it's just good stuff, and we're hoping that you guys will take a look at it and consider its deployment. With that being said, are there any other questions out there? I see one here. Dan, I think this probably is something for you. Are writes committed locally and then destaged to the copies? Dan, are you out there?
He's muted.
Toggle my mute. No, they're not. They're not committed locally. They're committed across the necessary fault domains to achieve the resilience guarantee. So, simplified, if I have a three-way mirror, I have to commit the writes to each of the three nodes which have the mirror of the given extent that I'm writing. Those do go into cache, so they're fast, but the data does land in all the fault domains before the write completes. We guarantee data resilience as, you know, that's the ultimate guarantee we're providing. When a write completes, it is durable in that system.
Okay, thank you.
And I'd also like to just follow up on that question. I have looked it up now, and yes, the second commandlet that was on my slide, that new NetQoS traffic class, it does require the DCB function or feature to be installed on Windows Server, but it still doesn't mean that you need to configure DCB on the NICs or on the switches.
Aha, there you go. Hopefully that answers that question. Anybody else? Okay. Well, thank you everybody for attending, and particularly I would like to thank Paul and Dan for helping me out today. And everybody have a great day, and take care.